The last force diagram in this series is the bowling ball rolls across the floor at a constant velocity. Here's the system schema from when the ball was sitting at rest. And now I have to think, are there other significant interactions occurring? The floor is still supporting it with the normal force up. There's still the interaction with the whole mass of the Earth, which is the gravitational interaction. There's a couple I might consider, and they are friction and drag. Those interactions would be with the air, and they would resist motion. Now, if this speed is not particularly high, drag would not be significant, and if it's a smooth floor, for a short stretch, friction would not be significant, and I will assume that they are not significant, and despite thinking about them, I will make a force diagram assuming they are not significant. So the force diagram, then, is there's the bowling ball. We have our gravitational force. I'm just going to write that. I know that that's the bowling ball right there, and it's by the Earth because of the other force diagrams we've done already. And then I know that the floor is supporting the bowling ball upwards, right? Otherwise it would drop, so that's a normal force. And after my thinking in my system schema, there is no other significant interaction. There's not significant friction or drag. There's not a broom pushing it. So that's it. And I do know that since there's no speeding up or slowing down upwards or downwards, that these forces must be balancing each other out. And that's the force diagram for the ball that's rolling at a constant velocity. So notice that this force diagram looks just like the force diagram as if the ball were at rest. And when it's at rest, it has a constant velocity of 0. So Newton's first law says that objects that are at rest or moving will stay at a constant velocity unless there's some unbalanced force, and there is no unbalanced force in this case, so the ball stays at a constant velocity. So just to reiterate, Newton's first law, known as the law of inertia, for these force diagrams, if we know that there's constant velocity, we know that the forces must be balanced, because objects at rest stay at rest at a constant velocity of 0, or objects moving at a constant velocity will stay at a constant velocity unless there's an unbalanced force.